Welcome back to Unraveling Human Physiology, where we try to make physiology easy for you to understand. Hi, in this video I'm going to tell you about body compartments and how we can estimate the volume of each body compartment. And I will also tell you what's homeostasis. I'm sure someone has already told you that you have to stay hydrated and drink lots of water because our body has lots of water, but how much water do we have? So here's our first key point. In our body, we have 60% of our body weight as water. And what's the meaning of 60% of our body weight as water? That is, if we weigh 60 kilograms, the total body water of our body will be 60% of 60 kilograms. That is 36 kilograms. And how do we relate kilograms with liters? Remember that water density is 1 liter for each kilograms. So if we have 36 kilograms of water, the total body water volume will be 36 liters. But wait, before we continue, we have to define what does it mean inside the body. It isn't so obvious what is inside the body and outside the body. If I ask you what's the limit of the body, you will surely tell me it's the skin. But inside the skin, we have cavities that connect to the exterior. For example, we have the digestive system, where we enter food and water, and we eliminate feces. We have the lungs, where we interchange air, and we have the kidneys, where urine exits the body. Let's add skin. We can see now those cavities I told you before, the digestive tract, the lungs, and the kidneys, and a part shaded in blue, which goes from the limit of those cavities to the skin. And that part shaded in blue is what we really call inside the body. A substance, for instance, food in the digestive tract, to be able to be inside the body, must traverse a tissue of a specialist cells called epithelia that are in every limit of these cavities. So the epithelia gives protection, so not every single thing that goes, for example, in the digestive tract or the lungs can actually reach the body. The skin also can interchange with the exterior, but very little, because water can't traverse the skin except from sweat. Let's go back then to the water. All the water that we have calculated, that we have this 60% of the body weight in water, is all in a ground space delimited between the epithelial walls and the skin? No. And here's an important key point. Our body is divided in compartments, so water will also be divided in compartments. You can picture the body as a huge orbis. Each bit of the orbis will be each compartment of the body. I thought of orbis because orbis can take water, as the compartments of our body. And which are the major body compartments? Let's take a tissue section. For example, the connective tissue. We can see here cells, interstices, and blood vessels. If we take all the cells of the body and we sum up all the volume of each one of the cells, and we make a grand compartment with the liquid which is in each one of the cells, we will have the intracellular compartment. And all the volume which is outside the cells but still inside the body forms the extracellular compartment, which is the boundary between the intracellular and the extracellular compartment, the plasmatic membrane. And here are a couple of extremely important key points. The fluids that form the extracellular compartment is called the internal media. That definition was coined by Claude Bernard in 1865. And even more important, as Walter Bradford Canus told us in 1926, this internal media is constant, even if external environment is changing. And this process of maintaining constant the internal environment is called homeostasis, and it's a key element to make our body function well. Inside the extracellular compartment, we have blood vessels. So that makes another limit. Everything that is inside the extracellular compartment but outside blood vessels is called the interstitial compartment. And everything that is inside blood vessels, except from blood cells, red blood cells and white blood cells, is called the intravascular compartment. What is the boundary between the interstitial and the intravascular compartment? The vascular endothelium. And here's an important key point: how much fluid there is in each compartment. So I told you that the total body water, it is 60% of our body weight. The intracellular fluid is 40% of our body weight, and the extracellular fluid is 20% of our total body weight. If you sum up 20 plus 40%, we have the 60% body weight, which forms the total body water. And in the extracellular compartment, we have the interstitial fluid, which is 15% of total body weight, and plasma, which is 5% of total body weight. This is very practical if we need to estimate the volume of body fluid that is in a specific compartment, for example, to calculate how a medicine will be distributed in this compartment. So let's take an example. If a person weighs 70 kilograms, his total body water will be about 60% of 70, that is 42 liters. The extracellular fluid will be 20% of 70, that is 14 liters. The intracellular fluid will be 40% of 70, that is 28 liters. The interstitial fluid will be 15% of 70, that is 10.5 liters. And plasma will be 5% of 70, that is 3.5 liters. And what if you need to estimate volemia, that is the volume of blood? Then plasma isn't enough because we have plasma and cells in the blood. But if we know that if a person weighs 70 kilograms, you will know that its plasma is about 3.5 liters. So how do we go from there to blood? We will need the hematocrit. Hematocrit will tell us the percent of the blood, which is red blood cells. For example, if hematocrit is 55%, that means that plasma is the other 45%. So, volemia will be the plasma divided the percentage which is plasma, that is 3.5 liters divided 0.45. Then volemia in this case will be 7.8 liters. Very nice. Just knowing your patient weight and its hematocrit, you will be able to estimate volemia just with some calculus. But there's a catch. Up to now, I'm told you that we are estimating total body water, because really total body water can vary a bit. For example, if we have more muscles or more adipose tissue, because muscle cells has 65% of water inside, while adipose tissue cells has only 10% of water inside. So if we have more muscles, we will have more body water, and if we will have more adipose tissue, we will have less body water. You can see that in the variation between sex. As other women has more percent of fat tissue, then women has less percent of water. So their total body water is a bit less than in men. And then we have the age factor. Kids have more percent of body weight as water than elder people. I have told you up to now 60% if for adults. For kids, total body water is approx 66% of their weight, and in elderly people is only 51%. And how can we calculate exactly the volume fluids of each compartment? We can use the dilution method. So remember, volume is a mass divided a concentration. So if we have an indicator with known mass and we have the concentration of this indicator, we will be able to estimate what's the volume where the indicator has been diluted. And which indicators can we use? For total body water, we have tritiated water. For extracellular fluid, we can use inulin. There's no way to estimate intracellular fluid with an indicator. We have to do the total body water minus extracellular fluid. And for plasma, we can use Evans blue. Again, there's anything that we can use to estimate interstitial fluid. We have to do the extracellular fluid minus plasma. And if we calculate plasma with Evans blue, we can then use the hematocrit to know what's the real volemia of your patient is. I hope you have enjoyed this video. Thank you. If you like this video, please give me a like, subscribe to my channel, and activate your notification to know when my next video will be on. Thanks, bye!